Hello everyone. Welcome to this video where I will be going through like terms. Okay, so in algebra we have got like terms. You see these x's, these pronumerals, these x's, y's, all these letters. We want to see how can we combine them. What is the right way to, add them, minus them, that kind of thing. Like terms, obviously they will simplify. Okay, so the first thing I've got here is you can see the difference between some terms that are like and some terms that are not like. Before this, what we want to determine is basically all pronumerals that are similar, right? X, X, these are like terms, right? But what if it was X and Y? These would not be like terms, okay? So the fundamental principle is they need to be like the same letter. We're not dealing with numbers, but we will be, but obviously they'll be connected to pronumerals. Of course, every number is a like term, right? You just plus it or minus it depending on what the question is asking. Okay, so we've got that defined. Now we've got a few of these questions here, or not these questions, but these examples. So 3x and 5x, 3x and 5x, these are like terms. Why? Because they both have this x. So what's important to note is that they have to have the same amount and the same type of pronumerals attached to the number. That's the most critical component. So you see the other one here, we've got 3x and 5y. There's an x and there's a y. That is why they're not like. Similarly, it doesn't matter if it's minus or positive in terms of the number. Minus 12a and 7a are positive. 11d and 4c are not. Sorry, not positive, they're like. 11d and 4c are not like because it's d and c. If it was 11d and 4d, yes, that would be a like term. But obviously, it's d and c. Continuing on, for these ones, where there's two or there's multiple pronumerals, it doesn't actually matter what order. So you'll notice here 5a and 6ba, these are the same, because technically this can also be written as 6ab, and this can also be written as 5ba. So these are both like, right? They're both equivalent. So it doesn't matter the order of the pronumerals as long as the same pronumerals are present. Okay, moving on, we've got minus 8ab and 5a. Obviously, these are not like because this is ab and this is a, so they have to have exactly the same terms, right? If this also had ab, then they would be like. Moving on, x squared, these are the same. And x squared and x, importantly, x squared and x are not the same. If you remember, x squared is actually, you can simplify this as x times x, right? Whereas x is just x. So this is why x squared is not equivalent to x, right? Because they're two different terms. One's got two x's times together and one does not. Okay, that's all well and good. Let's move on to a few practice questions that we can do using these like terms that we've just learned. So, these are simple addition and not multiplication, subtraction that we've got. So for question 5a, first we want to determine are they all like terms. In these questions, all of these questions, they all will be they all are like terms, so there's no problem with simplifying. Just a heads up, but yeah. So in this first one, we've got a plus a, and just be careful, it's 1a, there's an imaginary 1 in front of this. We don't write the 1 because mathematicians are lazy. That's what my high school teacher always said, at least. So yeah, 1a plus 1a is 2a. Okay, so you can go through these really quickly, right? You just need to confirm that they have the same like terms. They have the same terms, the same pronumerals in both the parts, and then you can just add them or minus them depending on what they want. So C is going to be 4 plus 3, 7b. D is going to be 12d minus 4d. Now, obviously, if we have a case, and we will have some more complicated cases. Actually, before I discuss that, you can see here we've got AB and AB. These are also like terms XY, XY. So you just do 4 minus 3 here. So XY and 12AB. So yeah, if they have two of these are still like terms as we discussed earlier. Okay, and also if this was 2BA, this would also be a like term because remember 2BA equals 2AB. It doesn't matter what the order is. Okay, that's very good. Now we will continue on to a little bit. Actually, before we go on to the next part, this is the thing that I wanted to show. So sometimes they'll give you questions. There are questions where some things are not simplifiable. So for example, let's have this question. Okay, so 12a plus 3 minus 7. So you really need to determine what are the like terms. And remember the like terms, as I said before, numbers are always like terms, right? So 3 and 7, these are like terms. And the 12a, you would want something else a, right? 5a if it was there, or 4a, right? If those were there, they would be like terms. And of course, something like 4a squared or 4ab, that would not be a like term with 12a. So that's not there. I'm just saying some examples, that's not there. So the only like terms here is your 3 and minus 7. So all you want to do is just do 3 minus 7. Just go from left to right here, which is minus 4, and then the 12a just stays the same. So in some questions, you don't have to simplify. For example, sometimes they can trick you, 4a minus 5. This is actually not simplifiable. It's just 4a minus 5, right? Because there's no like terms. 4a and 5, or minus 5, is not like terms, therefore you can't minus them. Alright, let's continue on to the next portion of the questions here, where we've got kind of those sort of questions where you've got not only just the pronumerals, you've also got numbers, and you've got other pronumerals present. So here we've got 7b plus 2 plus 3b, and again, we just want to be careful. These are our like terms. So underlying all of the pronumerals are a very good way of just identifying, especially when you're starting out. So that's what I'm doing here. So 7 plus 3 is 10, 10b. You'll also notice when you add, you don't add the b, right? You don't do b plus b as well. This is like incorrect, right? You just plus the numbers 7 and 3, and you just leave b the same. 10b and then plus 2, right? Plus 2 is the last thing. The next one, you'll notice all of these are like terms, right? They've all got the d, right? 12d minus 4d and plus d. So you just want to determine, what the minus and plusing is. So 12 minus 4 is going to be 8, and then I've just added a 1 in front of the d just to make it clear that it's 1d. So that would be 9d. Next question here, we've got a lot of terms. So again, very important. What I like to do is underline all of them. And another thing is underline the sign in front of it. Okay, here there's like an imaginary plus. But sometimes I like to do that if there's more simplifying that you need to do with other common factors. This is a minus 3a, this is a plus 4b, and this is a minus 2. So this will help you determine how to simplify all these like terms. Okay, so what are the like terms? 12a and minus 3a, so we can go through it like that. So this is plus 12a. This is why it's very important to have the symbol in front. So it's going to be 12a, obviously I'm not going to write the plus, not needed, and then minus 3a. So very important to include this symbol in front. So that's 9a. And then you can kind of think that, oh yeah, I've completed this. You can kind of cross this out from your memory. I'm not going to rub it out here because it looks a bit weird, but in your mind you can kind of erase it from your memory. 4b, well, you don't really need, you can't simplify this 4b, right? It's not simplifiable, there's no other b's here. And then you've got 5 and minus 2. And again, this is minus 2, this is not 2. If you do 5 plus 2, this is incorrect, okay? Does not equal 7. It's 5 and minus 2. So plus 5, right? The imaginary plus 5, minus 2. So 5 minus 2 is 3, so that is going to be your final answer. Okay, 9a plus 4b minus 3. We will also just complete the last two. Let me erase these. Okay. Yes. So now for the final two here, we've got, and again, this is the step I always want to do. Always underline all of your like terms. Okay. So for the A's, we've got 13a, we've got plus 2a and minus 4a. I also want you guys, if you're learning this, try to have the symbol in front as a part of your kind of memory for what it is, right? So it's not just 4a, it's minus 4a, okay? So I'm going to write all of these like terms that I found. 13a plus 2a minus 4a, and then I'm just going to, 13 plus 2, 15, minus 4, 11. So we've got 11a. And then we can move on to our b's. We've got plus 8b and minus 8b. Plus 8b minus, sorry, not minus 8b, minus 5b. And that's going to equal 11a plus 3b, right? 8 minus 3. Okay. And for the final question, we've got UV and UV. Very important. Remember the rule here. The UV is the same as VU. So VU equals UV. Because this can just flip, right? It still equals the same. Okay, this is a rule you want to remember. So these are like terms. So 12 UV UV minus 3 VU equals 9 UV. It doesn't matter if you write 9 VU or 9 UV. It doesn't matter the order, as I've been saying. And then also these are like terms. So 7 and 3, we want to add them. So plus 10 V. Okay, and that's going to be your final answer. Importantly, this cannot be simplified because this is uv, two terms, whereas this is just v. Okay, so you just leave that. And that concludes our session. Hopefully you learned something. Thank you very much for listening. Alright, until next video, I will say goodbye.